Are we live? Yes. So, good afternoon. As you know, this talk is going to be supposed about caching, so we have a caching problem. And we have a laptop problem. We have just all sorts of problems, but we hopefully will get through that. It's first time in my life that my laptop didn't recognize the HDMI, so I am running presentation on somebody else's laptop, which is extremely stressful in itself, but we'll see how it gets.
You look good.
Thank you. It's great to be back in Prague. I am extremely happy to have a presentation. I know that I'm this kind of an obstacle that is between you and the closing keynote, nearly. And you have this variety of Polish gang on other tracks, so I'm extremely happy that you came over here. And we'll talk a little bit about caching as a problem and also how we can mitigate some of the things that we have when we have this great idea, let's cache some data. But before we get through it, obviously there is this Slido thing, which Mark. There's this Slido thing where you can ask the questions, and that questions will magically somehow get to the screen at some point. I don't know how it works, but it's just magic. So please. Yes, we'll talk about caching because I professionally work in Hazelcast. Hazelcast is one of the caching platforms, or in-memory data platforms, and that entitles me to talk a bit about it. The other thing that entitles to talk about keeping data in memory is I have a lot of cat pictures since I started to work remotely. Also, one more thing about myself. I came from Poland, which is pretty close to Czech at the moment. I was surprised that the trip took so long, but it's just a matter of time that the next GeeCON will be by the sea. The next GeeCON Czech will be by the sea. It's just a matter of time. I know that. So let's get to business. Every even technical presentation needs a story because it's better when things have story. So let me meet James. James is a student in Prague Technical University, whichever technical university, and James has this ingenious idea for a startup that will make him rich, as every student has. And James thought that I will build this app, which you can tap. And it's very good because when you sit and hang out with friends and you just have a couple of beers or shots, depending on the country you're from, you think, okay, it might be a great idea that we'll start tapping into our mobile screen, and whoever taps fastest with more taps in a certain time slot wins. Ingenious. It was a very simple application, so it pretty much was about two endpoints. One was about tapping, and the other was about figuring out who won. And it all went to the SQL database. You may laugh, but actually a lot of applications are built that way. It was supported by two very profound SQL statements. One to insert the data into the database, and the other to query. That's all. And, you know, the god looked at the architecture and on the design and thought it is good. So things started rolling, and James started going out with friends, playing around. The app got more and more traction. It was still very simple. Some user code, some user was tapping on the app. It went to the app, straight to the database. Nothing fancy. It was even had a most significant and most popular architecture of application, 2 boxes and a cylinder. And surprisingly, these things do work. And implementation-wise, there was just a service that was putting data to repository and then pulling out data from repository. So essentially, the cleanest code of all clean code possible. Until AMP got so popular that when people start using it, more than in a single room, the app got crashed. And James starts thinking, what to do? I have to fix it quickly. You know, it's like severity 1 incident on production. So he thought, I'll cache all the things. Because that's what you usually do when you have a performance problem. You cache. Or you think it will solve your problem, and we'll get through that it won't, but for the sake of the presentation, let's pretend it will. And when it comes to caching, we ultimately know that there are only 2 hard things in the computer science, as cache invalidation and naming things. And you might think it's a Twitter meme. Phil Karlton doesn't exist. Well, he was a real person. He was working in a Netscape. Who remembers Netscape Navigator? Nice. Who remembers Mozilla? Nice. Who was using browser-like links? Shit, I'm not the oldest one. Yes. So whenever we introduce a caching into an app, this invalidation becomes a thing. Because ultimately, what's going to happen, and that's what happened in James' application, he turned from just writing down stuff to the database into this dual write problem where he set something into cache. And then he also saved it in the database because, you know, you have to have a persistent store, a durable data set. And then when he was trying to get the leaderboard, get all the results, he was getting it out from cache as well. Simple as that. But you know, I know that there is a saying that if it's stupid but it works, it ain't stupid. So is this simplicity, there is something that attracts us, but it also brings a couple of implicit problems that we'll cover in this talk. So the first problem he encountered was that his beautiful service became a little bit complex because he not only had his repository, but also he had some caching thing. We'll just use concurrent hash map for the sake of simplicity here. And not only he had to put something into the database, he also had to put something into the cache. And then he had to pull on something from the cache as well. So what he started doing, getting a little bit scientific, can be described as a cache-aside pattern. So we have our source of truth, our data storage, and we have cache. The cache can be embedded to the application, it can be something else, but there are 2 separate things. And you manage them separately. So once you set the data to cache, you also set data to your storage. And in similar way, when you read data out of cache, when it returns null, you have to go out to the storage, check, okay, there is data, return it, set to cache again, and then return it to user. So this has some pros and cons. The good side is anybody, literally, my mom, can read it and comprehend what's going on here. This is so simple. There's no magic. Everybody can understand it. So if your team is just junior interns, that's probably what they will figure out easily. On the downside, we have a code that handles 2 responsibility. They orchestrate the whole execution flow between the cache and the source of truth. So in our code, in our beautiful business application service that was supposed to do this businessy thing for business people to read sometimes, they have this infrastructure thing with all those merges and technical gibberish, which we don't really like. And handling those edge cases, what if one part of my solution is not available and I have to, do all kind of weird stuff. So not only the problem was in the convoluted code, but also that our beautiful simplistic architecture is becoming problematic. Because imagine that we not only have to scale the caching platform or scale the database, but we would like to also scale the application services. So we not only have a problem where we persist data, but also where the application runs, we would like to scale it out horizontally. We would like more instances of our app. James hasn't thought about it, so he had just a single instance at the beginning, but once he would like to scale out, that's going to be a problem. Because with this embedded caching aside, we had some subset of our data on each and every instance. So we can't go really for high availability without compromising consistency. And that's something that people not always think about. So we had independent cache on each and every node. And there is this inconsistency between our source of truth and our cache. And yeah, so how we can go around it? Maybe we can introduce a separate instance for cache. So now when you have any experience with in-memory platforms, so yes, there is this AWS service called Elastic Cache, or Google called, I can't remember. There are these services that pretty much does that. You have a separate instance where you can put your data, and it's fast as in memory, and it kind of gives this promise of speeding up your application. But it comes with yet another set of problems. So now we can go for high availability because our cache is somewhere else, and our application services can scale out, but we still have this inconsistency gap between instances, and we still have infrastructure code mixed with our application, and on the top of that, we kind of have distributed transaction because we have to do 2 hops over the network to figure out how things work. And we have another hardware component to maintain because that cache thing, that cache box is something we have to manage. And we usually don't think about it when we start, but yes, that's something we have to manage. So essentially, what we're trying to figure out now, from now on, is how we can make it better when it comes to initializing the cache, so our map that keeps our tapping entries, and how we can manage this dual write thing. How we can manage that whenever we insert something to the database, it will get into cache. Or if it don't get there, we'll retract the transaction from the database or any other way around. So that will try to minimize this inconsistency gap between one and the other. Let's put it on a different slide and have some ideas how we can do it better. So the hardware component, a little bit simplistically, but I can say let's go to cloud and let that not be our problem. We'll get to that. When it comes to distribution transaction and the inconsistency gap, there are different patterns for caching. One of those is read-write-through pattern, which I'll cover in a second, that kind of let you mitigate that. We'll still handle the distributed transaction, but we'll kind of offload it from our application. And we'll still have this potential inconsistency gap, but again, that won't be our problem as application developers to minimize that gap. And the third thing is the infrastructure orchestration. We don't want it to our application, so we would like to set a unified storage layer in our app. Whether it's in-memory data platform, whether it's SQL repository, whatever we just want, we just need a single layer for that. So let's start with cloud. Yes, memory store. That's the Google service. So we have all the cloud providers have different in-memory storage capabilities. As Hazelcast, we obviously have our own managed service where you can get Hazelcast in the cloud. It's called Viridian. I wanted to demo it, but due to laptop problems, that's going to be hard because it's the first time I'm touching a MacBook. Yeah, that's... yeah, I promised myself I will never get a computer more expensive than my car. And friends told me, you shouldn't drive 20 years old Peugeot. That might be one source of this problem, but yeah. Anyway, so you can go to the cloud and you can you can get away with this managing your own infrastructure part. You can just go take a service, you get an API keys, and you can move on. Let's leave it as it is. So let's say we have this problem figured out. The other thing is how we can minimize the gap between our cache and the storage. So what we would like to do is we would like to, instead of a dual write, we would like to have a situation where a user sets some data in our codebase, or sets some data, our codebase sets it in the cache, and the cache magically persisted in the database. Sounds okay? And then when we are reading stuff from the cache, we again interact only with the caching or in-memory platform layer, where we try to get something from the cache, and if it doesn't exist, the platform gets back to the database, figures it out, oh, here it is, and sets it in the cache and returns. So we want to offload like completely the operations with the database, and we would like to only interact with the caching platform. What it gives us? Well, we have this separation of concerns. Our code is talking with a storage. We don't really care what the storage looks like exactly, and we don't have it. We don't need to manage, orchestrate it within our code base. Our code interacts only with cache. There's no infrastructure plumbing code. You might say, hey, there is still transaction. There is still inconsistency gap. Still, this set in the store might fail, or you can have connectivity problems. Yes, that is true. But let's say we delegate it to a bunch of professionals who know how to manage that, who know when the retrials make sense and when they have to return you a failure. Because depending on the configuration of like Hazelcast or any other platform, you can say, fail to put into the caching platforms if your underlying database is problematic. Or you can say, I don't really care if it gets to the database instantly. We can offload it, save it asynchronously in batches after no longer than 1 minute. Because for me, latency and getting data in cache is the most essential, rather than persisting it for the future. And this is something that, as a developer, we not always think until we figure out in some documentation that, oh, that's an option. I have to think about it. Do I need it or I don't need it? So we can just delegate it to somebody else. How it's looking in practice? There was our service that we initially had the tapping thing managed. And look at that, we just have some cache implementation, and our code is only talking with cache, assuming that cache is kind of following some of the map interfaces where most caches are. So we have a single layer to interact with, and everything gets in the background. That was supposed to be nearly demo time. I will not apologize once again, but in Hazelcast, the offloading to the database looks in a way that there is an interface in Java which you can implement, which is called map store, where you can say, this is my key and this is my entry, and whenever anybody will put something into Hazelcast, it will be instantly saved into the database through this repository. And up to your configuration, it's whether this is synchronous or whether this is asynchronous. And the same goes for loading, for deleting, and so on and so forth. But then you can start to tweak it. So for example, you have volatile data in cache, but you want to persist it forever. So it's like session. So imagine you have a user session in the application, and you want the session to expire after 5 minutes of inactivity, or 10 minutes or 20 minutes, depending on the app. Bunks want 5 minutes, and I had them for that. But at the same time, you don't want this session data to be deleted forever. So you can keep it in cache, save it to the database, but then when cache is evicted, you can never delete it from the database and treat it as an audit record and have it forever. It's totally up to you and up how you design the system. So that is a map story. Map story is bound to a life cycle of each and every entry and the platform. So kind of the platform starts managing when things happen, and we don't have to manage it as a developer. Yes, there was supposed to be a demo. Sorry, I can do it independently after the talk if somebody is interested, but sorry for this inconvenience. But that covers the distributed transaction, which we still have, but somebody is managing that for us, not our code. So that way, or at least I have this principle, that when I know that I can get something done by a third party, which I trust it's done pretty well, and that's kind of their professional career built on doing it well, I have more confidence in that than my own code. But to be honest, I have very little confidence in my own code as well. And the consistency gap between cache and the storage is minimized, because every entry and every persisting the data is tightly coupled to the lifecycle of my data in the caching platform or in the memory platform. But we still have this orchestration code, mixed with a business code, which we don't like. So that was it. One thing was the read-through cache, where we have some caching implementation and our code was only interacting with cache. But one of the common patterns for the introducing caching as a performance boost to the application is that we have this application that was written 10, 15 years ago. You know, the oldest person working on this app haven't even met the original creator because they have left the company a couple years earlier, and it's like pure legacy. And when you have this legacy problem, the ultimate goal is, if it works, don't fix it. And if it compiles, don't touch it. So this idea that you will start fiddling with a service to introduce some additional layer of interaction with the data is very useful for a new application. But if you have a legacy or a certain level of legacy, that's not necessarily what you would like to do, because it will require ultimately changing a whole lot of different services. And that can cause bugs and problems, and it's not even unit tested or integration tested, because, you know, it was written so many years ago that people consider testing for testers. So what else can we do? Many of the the data platform, the in-memory data platform, like Hazelcast, but also others, come up with a different idea. That we initially started with a repository, and in our repository, we have SQL queries. So maybe we can use the same language, SQL, as a way to interact with any data platform. So the thing is, SQL is a language like Java, the only successful fourth-generation language, but still a language. And SQL doesn't imply that underneath is a database. And that's quite important, because people see, oh, SQL is a database. No, because database is ACID. And your platform that you are talking in with SQL might not necessarily be ACID as in the database. It might be non-durable. It might be not atomic, and, well, none of ACID can. It can adhere to none of the ACID. Nonetheless, we can interact with the database with a SQL. So maybe we can introduce a cache or in-memory data through the repository, not touch the services, and try to interact with the caching platform through SQL. Hazelcast supports that. There is a Hazelcast JDBC connector. So if we had our repository, which was SQL-based, we were interacting with tables. So in the beginning, we said like this create table something. For Hazelcast, there is no concept of table, but there is a map. And you can go and create a mapping, and then once you tell Hazelcast that in this map where I keep the data, this is the structure, and the structure is like JSON format or whatever, the variety of options which you can use. You can start interacting with your cache through SQL. So instead of injecting a Postgres data source into your repository, you can inject Hazelcast. And you can wrap the Hazelcast driver into a standard, in this case, Hikari, and put it into your repository. So you can even minimize the amount of changes within the app itself, so that the rollout of caching, if it's needed, is smoothless and easiest possible. So that way, damn it, those 7 minutes for the demo. That way we covered all the different problems that can happen when you start introducing a cache to a platform. So let's wrap it up. Initially, you start with a cache site. Very easy, but also very limited. Application handles everything, which is both good and bad. You know, we just had this discussion whether generating a sequence, generating an identifier which is non-numeric for an app should be done within an app or within a database. You know, your application can handle anything, but you have to do it consciously. The read-write-through thing is usually the best default because you want both fast access to your data, but also the persistence capabilities. So this is available, for example, in Hazelcast open source. This is available in Hazelcast platform with a free tier. For some other vendors like Redis, this is only the Redis Enterprise. And you have to plump a little bit of Python script onto the top of that. You can also write things behind, so you can say it's asynchronously and so on and so forth. But when your data platform is capable of doing something more profound than just storing a data like Memcache, you can start fiddling with yet more examples. Because what you can start doing is kind of refresh ahead. So you can start pre-computing the data based on what you have in your data platform. Think of like stored procedures, but not for databases. And you can start doing all this funky stuff with your data platform. So for Hazelcast, what we'll be addressing here is this part when we computed the leaderboard. So we try to pull the data from the cache and then figure out who won, what's the scoring, and kind of aggregate it. We could have done it in the app, like here. Works. That's a little bit CPU heavy, and there is a lot of back and forth on the network because we have to pull out the data. We could have done it on the SQL, which was close to the data, where we do a select with aggregation with some group by, and that was fine. Again, a little bit of CPU, less network transfer, but it works. But we can also do it on any other, like in-memory or like on some in-memory platform. For Hazelcast, we can define it like when you have a map. There's a lot of code which I won't get through, but if you are capable of looking through the stream API in Java, that looks familiar. So we have this read from something, it's a map, then transform it, get the value, group by tournament ID, and then start doing growing aggregates. So try to aggregate data as they flow, and finally sync them, so save it to yet another map or sync or data source or database, wherever. So you can start addressing computation capabilities next to your storage. So yes, in-memory data is getting closer where the database are, but they are not databases. So that was from me. 7 minutes is the demo, so sorry for that. I'll fix it again next time. And thank you very much. If you have any questions, Slido, I have to open it. Michał. Never touch somebody else's MacBook. That's what they told me. People get very anxious when others look while they're typing, especially with like a few hundred. But we are with you.
You can entertain the people.
Well, I have a 10-year-old kid, and I have some jokes, but I don't think they are appropriate for that audience. Because they are like, if you can think about dead jokes, the jokes that 10 years old are bringing is this level of jokes. For the joke? Not one. Okay, what's the name of the cat? So there is a story behind that. The cat is 19 years old. And she's in very good shape. But once we got her 19 years ago, we thought, oh, you're so young. Let's call you Young. Ain't valid anymore. She's 19 now. But that's kind of her official name. I regret it sometimes, but sometimes it's fun. I was like, what's your name? What's your cat's name? Oh, it's Youngie, or Young, or Młoda in Polish. I was like, how old is she? Oh, it's 20. Okay. When you're saving data from cache to repository during offload, how do you prevent losing the data when exception occurs? So it depends on the configuration, how you manage or how you configure your map store. By default, the operation to the cache is strictly bound with the operation to the data store. And it's kind of a synchronous call. You won't get an acknowledgement from the cache, from Hazelcast, that your data is successfully saved until Hazelcast doesn't get the acknowledgement from the database that it's successfully persisted. So it's a synchronous operation. And that way, when there is an exception in storing, you get an exception in putting the data into the database. Works for some use cases. For some use cases, people don't really care if the exception occurs because they have other means to reconcile the data. But essentially, this question brings you to how do you handle inconsistency in your application? When adding a cache like a Caffeine or Google Cache or even concurrent hash map to your app is very easy, people tend not to think about this kind of problems because essentially you will have to do the same. Now Hazelcast or any other platform is handling you. So there are means to make this call synchronous. If you set right behind to like more minutes or more seconds, yes, there is an inconsistency problem because your data will be asynchronously loaded to the database. If the exception occurs, that won't impact your caching data. It will be already there, but it will not be persistent. So we have to figure out some different ways how to manage this inconsistency. That's something which is very application dependent, and obviously there is no generic resolution for that. What are the best practices for cache invalidation? The default for Hazelcast is usually time to live, and that's how you usually think about things like login session. So you measure how long things live from the last touch. But then you can deploy different means depending on your use case. Sometimes your data are valid as long as somebody doesn't delete the account. You can manage. In Hazelcast, again, I'm working in Hazelcast, so obviously I have more most of the reference there. You can introduce something called entry processors and event listeners. So whenever you add data to Hazelcast, you can process it additionally. That can help you handling the cache invalidation if it's more subtle or more complex example. next one, how does Hazelcast differ from Redis? My favorite question. Obviously, Hazelcast uses client-side cache, the client process. Yes, well, Hazelcast comes with different flavors. So on a very high level, you can say each and every one is a cache. There is a difference in the way the actual platforms are architected. There is the difference how they scale with traffic and how they scale with load, which is different. When you look at the benchmarks between Hazelcast and Redis, they different on the performance when there's a lot of data in the caching and you just add more members. So that's it's different than Hazelcast is using client-side cache. Well, you can set it like this. So Hazelcast comes with a client that can be a light member, so that it can contain some near cache data, and it can be with your member. But the difference is with your application. But the difference is that this thing. This client doesn't contain a partition, so it does participate with actually handling the storage or persistence of the data. It just has a near cache view of the data. So again, you might hit this inconsistency problem as you have in the cache side, but on the other, you have a very low latency. So all depends on the use case you are trying to solve. Can I implement the top game and become rich? Yes, of course. Yes. For fuck's sake, yes. That will be something to play here. What do you use for graphics in your slide? It looks awesome. It was an iPad and a stencil. I drew it myself, but thank you. Hazelcast caching looks like another implementation of data access object layer, isn't it? So service is not aware that cache even exists. Yes, you can implement it that way, that your caching platform is just another data storage, and whatever happens underneath is an implementation detail from an application standpoint. That's usually a good approach, unless you either have something extremely complex or you haven't read the docs. Given that I need 2+ cache instances, nodes, an update operation, not just read-write, would you recommend using cache at all? What about nodes consistency? So each of the in-memory data platform is trying to solve actually this problem. Obviously, that's a distributed data platform, so you usually don't go for 2+ cache nodes, but rather 3+ to formulate a cluster. So I can tell how it works for the Hazelcast. Whenever you write something to the Hazelcast, each of an entry by default has at least one backup on another node, and you don't get acknowledgement from Hazelcast until the data is successfully persisted on the other node. So we kind of handle the replication of the data between the members, how we refer to cache. So when your app is talking to member A, put some data, and this gets replicated to member C. You get an acknowledgement after the data is successfully persisted on the other member, and Hazelcast handles it on its own. When you go Redis, they have not a similar, but different, but also this kind of mechanics to make sure that the data gets replicated. If you go for something extremely brutal, like memcache, they don't care. Memcache is just a single instance, and you put data as long as you can throw it in. And then if you would like to formulate a cluster out of a vanilla memcache, you'll have to handle it on its own. That's the difference. That's pretty much what you maybe not necessarily pay for, because Hazelcast is open source, but that's what you get in the managed service and so on. How you scale Hazelcast across multiple nodes instances, ideally from internal perspective. I think I just described how it works. I don't know who asked the question, but that's pretty much. If I haven't described it if I haven't answered in the previous one, just come over and we can drill out the details. Would you consider to add microscreen persistence to Hazelcast mappers? So Hazelcast does not provide any special implementation for the mappers. It's so simple that we just leave it as it is. The only thing that is coming in the next release of Hazelcast will be generic SQL mapper. So SQL is so popular that it's worth doing a mapper. I have never used MicroStream. I've seen they have a booth over here, but I've never used. So we, as a Hazelcast, we don't provide bespoke mappers. It's very simple to write it down. So we just leave it. Which query languages are supported by Hazelcast? So Hazelcast has its own clients in different languages. So we have, again, no demo, so I cannot show it. Damn it. Java, JavaScript, Python, Golang, and CLI. So CLI is pretty nice for just interacting with a SQL. Python works successfully with Jupyter notebooks. And obviously Java applications are working with Java. So these are kind of vanilla programming language, and there is a SQL. We support, I'm not SQL expert, so I can't tell you whether it's ANSI 92 or 96 or whatever, but we kind of claim that we support SQL. Does Hazelcast has anything to do with hazelnuts? I'm too little in the company to know the answer to this question, but that's not the only thing that we wonder about. Our HR officer, as Hazelcast has an office in Turkey, is called Hazel, which is a valid Turkish name. And we sometimes think what she is casting. Can I use transactions with your cache? That's, I think that question's just opens another question. Do you mean a transaction on an application level? Yes, you can wire acknowledgement from Hazelcast with your transaction manager in your application if you are using Spring or Java EE something. Hazelcast gives you certain guarantees on the atomicity of an insert, but we don't really provide any transaction among multiple maps and so on. In a similar way, for example, like Kafka does not provide transaction among different partitions. In the code at the beginning, concurrent hash map. Oh, yeah, thank you. Concurrent hash map, you don't mention cache eviction. Yes, that was exactly the point. Concurrent hash map doesn't really cover cache eviction in an easy way when you do instead of a concurrent hash map, which is the easiest one to handle. Something like Google Cache or Caffeine, then you have the evictions out of the box. What's the difference between grid gain? Grid gain is our competition. I think that's the whole story. At least on the record. How would you do your cache read-through with Hazelcast baked behind the SQL data source? Would it be a pipeline from... yes, more or less, Hazelcast quite often stands in front of a database. Among other tooling and plumbing and Hazelcast, we do support CDC, which is change data capture, and I just lost the name of the Red Hat product. Debezium, yes, thank you. So quite a common use case that, especially in this read-ahead example, that you configure your Debezium in a way that your insert or your changes in the database are captured and sent over to Hazelcast. That's quite a common use case. And yes, then you can implement that was called Jet Pipeline, where you can fiddle with this source in any way you want. Does Hazelcast in write-through mode supports transactions spanning multiple calls, inserts with correct rollback? So MapStore works in a way that it comes with it's an interface. It's a Java interface which comes with a store all, load all, and so on and so forth. So it's up to you implementing the map store, how you want to manage that. If you get a single record, obviously it's a single write. If you get multiple records, it's up to you how you manage the transaction with multiple entries. Hazelcast, even if Hazelcast aggregates in the right behind in kind of batch mode, you still get it all into a single method on your map store, and then it's up to you how you handle the transaction. Read-write pattern interacting with the cache only looks like implementation of a tab service of a tagging repository. Why do you consider is a separate layer of an app? Because it works nicely on slides, especially that's simple. But I kind of want to show you a small slice of a bigger app. Let's put it like this. I know that there is this pattern that you have your entities to the database, and you put it all the way through the REST interface, which I consider slightly anti-pattern. But usually you have this separation of service and repository. Sometimes it's as simple as it was here, but sometimes it does a little bit more. So that's why I kept it, just for people to, at least I thought, for people to get their head around better. I can't really answer the last question. And that's it. Thank you for that. If whoever wrote the last question, if they come over and we can drill it further, maybe I know the answer. Or maybe I can drive to part of documentation. Thank you very much. Enjoy the break and final keynote.